Question number 2. So this graph is a graph of velocity against time for a cart in a physics laboratory. So we have to describe qualitatively the motion of the cart and determine the total distance traveled by the cart and its displacement, and lastly calculate the average acceleration between 3 to 14 seconds. So between 3 to 14 seconds is somewhere here. 1, 2, 3, 4. Yeah, 3 until 14, which is here. Okay, so we have to calculate the average acceleration. Now let's describe qualitatively the motion of the cart lah. So from 0 to 4 seconds. So from 0 to 4 seconds here, the cart is shown to be moving. So the cart is moving from the start, but the velocity is decreasing uniformly. Okay, so it is decreasing uniformly, and then what should we write? We until it stops. So it goes to a stop at this point here. Okay, 0 to 4 seconds. Here. So from the start, it is already moving and going to a stop here until it stops for an instant to change direction. Okay, and then from 4 to 8 seconds pula. So from 4 to 8 seconds is from this point ish, and then 5, 6, 7, 8 is this point. Okay, so this is 5 from 4 to 8 seconds. So if we look at this, it should be up till this point lah. Okay, so if we look at this point here, the velocity, just this spot here, is increasing. Okay, so it goes from 0 to a greater value, but in the opposite direction lah. So we can write the cart, why is it blue? So what we can write is the cart moves in the opposite direction with increasing velocity. Okay, so why did I write increasing velocity is because if we look at this graph, it starts to go from 0 to 4 meter per second. So that is a much greater value than 0 lah. Okay, and then i.e. it is accelerating lah. Okay, so it accelerates, and then from what else? From 8 to 12 seconds. So 8 to 12 seconds. 8 is until here lah. Okay, so we're gonna refer that one. So if we look at this, the object is moving at a constant velocity. So we can write the cart is still moving. Let me just write it down. So the cart is still moving in the opposite direction. Why did I write in the opposite direction? Is because it is still at the negative value. Okay, so it is still moving in the opposite direction, but with a constant velocity. Okay, next we can write to this point here. So from 12 to 16 seconds, we can see that the cart is decreasing in velocity. So it goes from 4 to 0 meter per second. So what we can write is the cart moves in the opposite direction because it is going from a negative value to a positive value, which is 0 lah. So the cart moves in the opposite direction with a decreasing velocity and then comes to rest. Okay, so at the certain point it comes to rest lah. It stop. Itulah maksudnya. Okay, so that is how you describe qualitatively the motion of the cart. Okay, and then we have to calculate the distance traveled by the cart. So the distance traveled by the cart is just, I'm just gonna write here. So distance is just speed times the, multiply with the time. Okay, speed darab dengan time equals to distance. So what we can do is we can label this as x, y, z. X, y, z. What else should I write? X, y, z, l? No. P lah, P. Okay. So for the area ataupun the area under the graph lah maksudnya. Okay, so I'm not gonna write down the area lah, tapi I'm not gonna calculate. Should I? Okay lah, let me just write it down. Actually, sorry if I'm confusing, but let me just redo this. So if we look at this is actually a trapezium, if I'm not mistaken. Is this a trapezium? I think it's a trapezium. Let me just double check. Again, you can skip this part. Trapezium. Yes, so this okay. So let's calculate the distance. So the distance is the area under the graph. So this can be one part, and this part here, which is a trapezium, can be calculated as one part. Okay, so x is just the triangle, so half times 4 times 4, and then y is a trapezium, which is half times dengan 12 plus 4 times with negative 4. Sorry, no negative 4. This is direction. Sorry. Times with 4 lah. So plus this, and you'll get the distance to be equal to 40 meter. Okay, and then the displacement is the same. It is the same with this, but you just have to add a negative value, which is negative 4 lah. Why is it negative 4? Because this point here, it changed direction, so the displacement is different. So displacement is going to be negative 24 meter. Okay, and lastly, you have to calculate the average acceleration. So the average acceleration is delta v divided by delta t. So it is from 3 to 14 seconds. So from 3, so this is 3 to 14 seconds, which is this part here. So we have to calculate the average acceleration. So the delta v is from this one, which is 2, and then this is 1, and then 14 is this part here, which is negative 1, negative 2. Okay, so delta v is negative 2 minus 1, delta t is 14 minus 3. Okay, remember this is v final, v initial divided by t final, t initial. So the average acceleration is going to be negative 0.273 meter per second square. Right, so that is the solution for question number 2.